Hey Bears, I'm going to do my best to keep this one short, I promise. We've been talking about oxidation numbers for a little while now, and we've taken notes on it, and I've asked you to write it on over and over. So I'm going to record this, so now I can just say, hey, go check out my video. All right, so here we go. Remember, oxidation numbers are when atoms or molecules will either gain or lose electrons. If we end up with a positive oxidation number, typically that will be a metal that has lost electrons. An element, we call those cations. Elements or atoms that gain electrons, typically nonmetals that we call anions, will have a negative oxidation number because they've gained electrons. All right. The positive and the negative tell us whether an atom has either gained or lost. And the number itself tells us how many electrons were either gained or lost. So we're going to start with the alkali family here. Alkali group 1, alkali metals. Remember, we're getting into talking about ionic bonds, and ionic bonds are between metals and nonmetals. So our metals are all in this area. Probably not the best color choice here and highlight, but I do again want to point out the majority of the elements on the periodic table, or the majority of the elements that exist, period, are metals. And then we have our nonmetals, which include hydrogen and these guys over here. And then you have your metalloids, which are kind of funky and do their own little thing. But nonmetals, looking mostly starting with the carbon all the way to the noble gases. Okay, so back to it. Oxidation number for the alkali group 1 is a plus, oh, terrible color, +1 oxidation. They lose 1 electron when forming a cation. Group 2 metals, the alkaline earth metals, these guys right here, have an oxidation of a +2, meaning they will typically lose 2 electrons when forming a cation. We jump the transitions because you have elements like iron and copper and some other metals that have various oxidation numbers. They can have different types of oxidations, and we'll talk a little bit more about that later. So we skip over those guys and move over to the boron family, which has an oxidation of +3. Man, I try so hard with this pen. I swear I do, and it still looks like a child's handwriting. There we go, 3, a little bit better. Carbon family is the next family. Have oxidations of a plus or -4. We don't have to use that family too often when bonding, so don't stress too much about that one. The nitrogen family, now we're getting more into the nonmetal side, is now a -3 oxidation, meaning they gain 3 electrons. The next family is the oxygen family. They will gain 2 electrons when becoming an anion. The next family are the halogens, which tend to gain 1 electron, so their oxidation is the -1. And the noble gases have a 0 oxidation, and the reason being is their outer shell, they've reached that P6 electron configuration, where they've maxed out their valence shell of electrons, and they're completely stable. They don't need to have any other electrons, so they're not going to gain or lose. And so from here on out, we're not going to really talk too much about noble gases, because they're very unreactive. We can force them to lose electrons under certain, circumstances, but for our purposes, for keeping, you know, on level chemistry, we're going to kind of steer clear of those. So there are your oxidation numbers. Your alkalis with a +1, alkaline earth metals +2, boron family +3, carbon ±4, nitrogen -3, oxygen -2, and the halogens -1. And it would be in your best interest again to get a periodic table and write these oxidation numbers down, because we are going to be using them for the rest of the year, and I would also suggest that you go ahead and just memorize them. All right, guys, that's it. That's the basic of basics in oxidation numbers.